until this point in Chapter 7, we have been working strictly with systems of equations. In sections 1 and 2, we worked with systems of linear and nonlinear equations with just 2 variables. In section 3, we worked with multivariable systems. They had 3 variables. But all those systems had equal signs. So we were looking for specific ordered pairs or specific ordered triples, that if we could find that XY or that XYZ, we would plug it back in and it would make all the equations in the system true. And we even had some examples where, like, if we had infinitely many solutions, we could narrow down that infinite set to the points that actually landed at the intersection of all of our equations. Okay. What we're shifting over to in section 7.5, and will be very useful to us tomorrow when we start linear programming, is instead of working with systems of equations, we're going to switch to systems of inequalities. So when I talk about an inequality, what do you do for inequalities in 2 variables? I'll give you an example to kind of get your mind thinking. Y is less than 2x plus 3. Instead of an equation, y equals 2x plus 3. What sort of things do you remember about inequalities? How about this? In your small groups, have a quick conversation. What do you remember about inequalities? What do you do with y is less than 2x plus 3? Only nice things about inequalities.
I strongly dislike
political.
Thank you.
In like a graph, the line
Yeah,
equals
that, like,
2x plus 3, but it's less than, so you got it dotted, and then you just do all of it, and then you just shade it below that line. Yeah, well, it's just like doing the dotted line of the y equals 2x plus 3, and then you just shade the y out.
Okay. Lexi, give me something you guys talked about regarding inequalities.
There's like, when you graph it, there's closed circles.
Okay.
When it's equal to or like less than or greater than, there's a closed circle.
Oh, and then there's also open circles, did you say?
Yeah.
Okay, so open versus closed. What else did you guys talk about, right?
They're unlike.
They're unlike. John, did you guys have anything else you could add besides open and closed? Oh yeah, if you're solving for a variable and you multiply or divide by a negative. Can't get that. You know what I'm trying to write. Then you have to flip the sign. So like a less than becomes a greater than, etc. Flip the inequality. Kelly, did you guys have anything else to add? Nothing else to add? But you at least didn't say anything about not liking them, right?
No, I didn't say that.
Okay.
I didn't say anything.
This is the United States. I thought we were founded on the principles of equality, not inequalities.
That's a funny joke, Mason. I like that one.
Katie, does your group have anything else to add?
When graphing, we talked about like shading.
Oh yeah, so along with open and closed, there's usually shading. And then I heard it out in the group when I was walking around. There's something else groups were talking about that's similar to one of the things that are up there, but a little bit different.
If lines like solid or if it's dotted.
Yeah, it's similar to this open and closed thing. So when you're actually graphing in 2 variables, instead of being on a number line and having like a closed circle and just shading right or left, Now we have two dimensions, x and y, so we're going to have actual shapes, right? Lines, curves, etc. So we'll be choosing between solid and dashed. But we'll choose solid or dash. We'll also do some shading, and there might be some solving so that we can get it to a graphable function or graphable equation. And so we might have to utilize that piece where if we multiply or divide by negative, we have to flip the sign. Okay, so first thing we want to put down in our notebook are some reminders, some tips for graphing inequalities. Okay. Main one I would say is don't forget that when you get to a system of inequalities, if you're graphing it, you have to decide between solid or dashed. And we already kind of went over when would it be solid. That would be the same as a closed circle. So anytime you have less than or equal to or greater than or equal to, you're going to create a solid curve. Okay. If you have less than or greater than, then you want to make sure it's dashed. Dashed is the same as open, so it's saying, here's the point that serves as a boundary, but don't pick this point because it doesn't work in the inequality. It makes it equal instead of less than or greater than. Now, as for the shading piece, which you guys mentioned, some of you have some different rules from previous math classes that you can work with and utilize, and if you have those rules to help you decide where to shade, you're free to use them as long as you're shading in the correct location. So some of those rules would be like, if you have a line y equals mx plus b, and then it's changed to an inequality like y is greater than mx plus b, some people know from a rule that if it's greater than, you just go to your y-intercept and shade up. Okay? And then if it's less than, you would shade below the y-intercept. If you have that rule from a previous class, feel free to use it. Just know that if you're ever unsure about where you should shade, you can always pick a test point. Okay? So when I say pick a test point, okay, the test point should be not on the curve. So I'm just going to look at y is less than x squared. That's the parent function for the quadratic. And I would have some points that I could graph real quick. And because it doesn't have the or equals to it, would be a dotted parabola. And then I have to decide, like, am I going to shade inside the parabola? Am I going to shade outside the parabola? Remember, some of you might have a rule for that. That's okay. But if you're unsure about it, pick some test point. And that test point can be anywhere. You might pick a test point that's inside the parabola. You might pick a test point that is outside the parabola. I'm just going to pick this point right here. I'm going to call it 0, -5. So 0 left or right, I'll go 5 down. This is going to be my x and my y. I'm going to plug it into that inequality and see if it's true or false. So is -5 less than 0 squared? Lillian is saying yes, of course it is. So that's true. If it's true, shade where the point is. So I want to shade, this should be part of the solution. It's outside the parabola. All of my shading should be outside of the parabola. If I had picked a different point, and I'll pick 0, 3, and I plug that into my original equation, then I would get something like 3 is less than 0 squared. How do you feel about 3 is less than 0? Not so hot. That's false. So if your test point is false, like my green point right here inside my parabola, don't shade where that point is. So that would have told me shade outside the parabola. So either way you do it, you're going to get the same location. Okay? If it's true, shade where the point is. If it's false, shade where the point is not. Okay? So that can always be your fallback if you don't have a rule for where to shade. Does anybody have any questions about that? Okay, I'm going to put up a problem, and I'm going to give you some time to kind of think about on your own how you might graph that, and kind of come up with your own ideas, and then we'll kind of come together and see if we agree. So I'll give you some, because most of this you could do on your own, I'll give you some time to see if you can do it by yourself. So here's, I'll come back to that. Here's your first one. So I'm going to ask this question. I'm going to start with actually the second inequality here, because this one I think probably everybody should have been able to graph x is less than 4. What type of shape are we drawing for x is less than 4?
A dashed vertical line.
A dashed line because it does not have or equals to. And then if you think about it in terms of an equation, what would x equals 4 look like on a graph?
Vertical line.
A vertical line. We saw those all the time with asymptotes for logarithms and rational functions, right? When you have x equals a number, that's a vertical line. So we would want to go right 4, and we would want to draw, like Mason said, a dashed line at 4. And that's my line x equals -4, but I'm not including it because it's dashed. And because it's less than. And then in which direction would you shade?
To the left.
You would shade to the left. Now, smartboard shading is pretty terrible, so I'm just going to like point to the left for right now. So we've marked that. We would be shading all to the left. Okay. Now, when you have a system of inequalities, the solution is really the overlap of both inequalities. So we have graphed x is less than 4, but we really need to focus on this -x plus y squared is greater than 0. And so some of us were looking at that a little bit puzzled. What are some solutions we could create for ourselves so we would be able to get a graph of -x plus y squared is greater than 0? Lillian, what did you think about?
Well, do I just say what I did? 'Cause,
Yeah, tell us about your thought process.
added x to the other side of the inequality, and then I square rooted y, so it's y greater than square root of x.
Oh, forgot to add x. Okay, add x, then square root. Y is greater than square root of x. What's the benefit to what Lillian's doing there? Like, why is she solving for y?
Because I agree.
Because when we graph, pretty much most of the time, things are in terms of y, right? Think about all the equations, all the functions we've graphed so far this year. Y equals, or f of x equals, right? So it's helpful for us if we solve for y. How then did you graph y equals the square root of x?
The parent graph, and then I shaded above the thing.
Yeah, the parent graph. Now, it's going to be really important for us tomorrow when we're doing linear programming that our graphs are accurate graphs. So aside from just sketching the parent graph, you might actually pick some points that are on the parent graph for the square root function. And so, since I'm taking the square root of x, I'm not going to put what type of numbers in there? Negative. So I'm going to start at 0, and I'm going to choose wisely so that I can take the square roots of the different x values. I'm going to choose like 1 and 4. So then I get 0, 1, and 2 as my outputs for y. So remember, what's the benefit of Lillian solving for y right there? So that she can like plug in different x's and get out y's that would be good to graph. Okay. Now, when you graph that, is that going to be a solid or a dashed?
It's going to be rather
Dashed. Okay, now, any other thoughts about graphing that you would like to add? Me.
You look rather displeased at me.
I thought Dylan was going to say something.
You gotta negate. That's like negative y is also a solution.
What do you mean?
Y squared, it could be y, it could be negative y, it could be posters, who knows. You gotta have both.
Where do you find that? So he's talking about negatives. And he's talking about y being negative. Where does that come from, Dylan?
Because square root could be both negative.
When we solve by taking square roots in algebra, do you know if it was a positive times a positive or a negative times a negative? No, you don't know, right? So like I gave Dylan asked me a question and I gave him an example. How would you solve x squared equals 36? Take the square root of both sides, and most people will say x equals 6. And then I asked Dylan, is that your only answer? No, that's not. Absolutely not. That's not the only number that works in x squared equals 36, right? It could be 6 squared, but it could also be negative 6 squared, and we still get 36. So up here, when Lillian was solving, remember that all of our solving rules from algebra still remain. When you solve for any variable by taking the square root of both sides, you must add a plus or minus. So we have to add that plus or minus, which means we just created a table of values for the positive version, y equals the square root of x. There is another part of this graph where y is equal to a negative square root of x. So if I do x and y, where y equals negative square root of x, almost got it. Then I'm going to get those pieces that Mason was talking about, because I could plug in the same numbers for x, 0, 1, and 4, but when I plug them in, then they're going to turn into negatives, right? So then I have the y values 0, negative 1, and negative 2, and I can plot those points. And that would also be dotted. So I also would say, think about it like this. When you see an x squared in an equation, you know the shape is going to be what?
A parabola.
A parabola. But in x squared equations, they always open up or down. If the square is on the y, then it's still a parabola, but it opens right or left. And we'll talk about that in second semester as a conic section. Now, it's not a function because it doesn't pass the vertical line test, but it's still a curved graph, so we're allowed to graph it. And so just be aware of that when you're graphing on your homework tonight. Think really carefully about the different types of shapes that you might be seeing in those problems. Now, we still have to decide for this parabola, because we know we're shading to the left of x equals negative 4. Are you shading inside the parabola or are you shading outside the parabola? How can we figure out where to shade?
Science.
Use a test point.
Yeah, use the test point, just like we did on that last slide, right? What's a point that's not on the parabola?
0, 1. Or 1, 0.
1, 0. It's inside the parabola. So we're just going to plug that in for x and y. That would be negative 1 plus 0 squared is greater than 0. How do you feel about negative 1 plus 0 squared is greater than 0?
I feel that's wrong.
False. Should you shade inside the parabola? No. You should shade outside the parabola. And remember, you're shading outside the parabola. You're shading to the left of the line y equals x. Or sorry, x equals 4. So then we have this shading. Don't go in your parabola. Stay outside the parabola. Shading on the outside. Yes, sir.
But the negatives, negative x values,
Mm-hmm.
they don't work in that equation though. That's right.
I'll be picking this point. This is negative 6, 3. Negative 6 plus 3 squared is greater than 0. So 6 plus 9 is greater than 0. So that's okay.
Forget it.
Yeah, so your issue with that square root and the negatives is about the curve, the actual blue dotted parabola, right? But in the inequality, you can choose numbers as long as they fit in the inequality. Okay? Good thought, though. I would argue that any of those points I test will work out and be true, so they should be shaded. They're part of the solution. Any questions there? Now, there's one other thing that the homework is going to ask. It says it right up there. Find the vertices. So the vertices are any of the points of intersection between two curves. So when I'm looking at this graph where I have the dotted line and I have the dotted parabola, I see two separate vertices. Okay, I see a point of intersection here and here. And so this is going to be really important for tomorrow, for linear programming, that you can find those points of intersection. Now on mine, they line up real nicely with my graph and my table of values. So I know exactly what those points are. 4, 2, and 4, negative 2. So there I have just labeled my vertices. Okay. I would like you to do that on your homework tonight. If your table of values doesn't go out that far, you could find your vertices because it's a point of intersection by solving the system of equations. You're just finding when they are equal to each other. Okay, any final questions on that example? Okay. Next example. So what I would want you to do, we have about 10 minutes left. What I really want you to do right now, read through the problem and then try to come up with the system of inequalities, right? So that we can challenge ourselves and see if we can do that. I'm going to say, I'll give you like a minute or two to read through it on your own. You can remember yesterday, those of you that were here, I made my own notes for like what was really helpful, what I was going to use to make my equations. So feel free to take any notes that you want from that. And then in about 2 minutes, I'll have you talk in small groups to try to brainstorm some inequalities that you might write. So read through it and kind of try to make sense of it on your own. Okay, let's talk. Are there any ideas out there that you would be willing to share? A brave, brave soul. Let me ask you this. In terms of inequalities like less than and greater than, what is your main concern in this problem? Less than what number, greater than what number, or expression?
So A has to be greater than or equal to 16, B has to be greater than or equal to 5, and C has to be greater than or equal to 20.
I think this, sentence that Mason just described right there is super important, right, to you writing an inequality, because it's talking about the minimum requirement. So you want A to have at least 16 units, you want B to be at least 5 units, and you want C to be at least 20 units. So then if we say at least, which inequality would we'd be looking for? Greater than or equal to. Okay, that would be like the bare minimum of what we would want. So I'm going to kind of, in my own sort of way, I'm going to say for A, I want at least 16 units. For B, I want at least 5 units. And for C, I want at least 20 units. Okay, so I want them to be greater than that. Now the issue is that you have different brands of dog food that you can buy, right? Brand X has a certain number of nutrients, 8A, 1B, 2C. while brand Y has 2A, 1B, 7C. So if you want your A's to be greater than or equal to 16, how many units of A do you get from brand X?
8, I think.
8 units from brand X, right, for nutrient A. So if I buy 1 bag, I'll get 8 units. I'll be halfway there. If I buy 2 bags of brand X, then I'll be up to 16 and I'll have met my requirement. How many units for nutrient A will I get in brand Y? 2. So if I buy 1 bag of brand X, then I'll only have 8 units of nutrient A. If I buy 1 bag of brand Y, then I'll only get 2, so I'd only have 10. Would that meet my requirement? No, I'd have to buy more than 1 of each. What would be the expression for nutrient B? How much are you getting from brand X? 1X plus, what's Y?
1Y.
1Y. So X plus Y is greater than or equal to 5. And the last one, it's hard for me to read this close. 2X plus 7Y.
Second that.
Okay. So like if you were here yesterday and we went over the fertilizer problem, we had to write out fractions because it would say like 1 part A, 2 parts B. So you had 1/3 of the mixture and 2/3 of the mixture. So we had to work in that lambda fractions because we were dealing with part-to-part ratios. Okay. Notice that here we're going from unit to unit. So we're not switching from ratios to pounds. We don't have to work in fractions. We can just use those actual coefficients for X and for Y. Now there would be 1 other or 2 other inequalities that I would add, and we're going to talk about this tomorrow when we do linear programming. In a real-world situation, we should add that can you buy less than 1 bag of brand X? No. So X would be greater than or equal to 0, and Y would also be greater than or equal to 0. If you would like a piece of graph paper to do your homework, okay, grab one from the person at the front of your row. I'll pick up the remaining pieces. That's